Hi, welcome back to physics. We're studying waves, which are disturbances which transmit energy through the universe via the vibration of particles. We've recently learned about one specific kind of wave that we use often, sound waves. Sound waves are longitudinal waves, and they can propagate through solids, liquids, or gases. Today we're studying another type of wave we use every single day, light. Did you know that light is a wave? Now you do. Light is a transverse wave. But unlike all of the other kinds of waves that we've studied so far, light is not a mechanical wave. Weird. All of those other kinds of waves needed some physical particle, air molecules, water molecules, molecules of wood or iron, something physical to be doing the wiggling and waving to send that energy from place to place. Light doesn't need that. It propagates right through the vacuum of space, all on its own. But if it's not a mechanical wave, what is it? Light is fundamentally an electromagnetic phenomenon. It's produced from the electric and magnetic fields of the very universe itself, which affect each other and oscillate forward, sloshing energy from one to the other. How cool is that? But where does it come from? Well, it turns out light, being an electromagnetic phenomenon, comes from charged particles. Any charged particle which accelerates will produce electromagnetic waves. What we see comes from electrons dropping from higher orbitals within their atoms to lower energy ones, which we'll study in more depth at a later time. This acceleration produces those waves that we see as light. Speaking of seeing, that's what we use these waves for the most, true? We need light to see. This can occur in one of two ways. First of all, some objects are themselves luminous, meaning they produce their own light. Light bulbs, of course, are luminous, and fire, stars, and the sun produce light in great quantities. Not many things fall in this category. Most of the stuff that we look at would be considered illuminated, meaning they are lit up by light from other objects that lands on them and reflects into our eyes. Look around you. Do you see any people, walls, trees, even the moon itself? All of those things are only visible to your eyes because something else made light, which is bouncing off that object, to you. To wrap up today, I'm going to give you a tool that we'll be using quite a bit in the coming days called ray diagrams. Ray diagrams basically take a series of wave fronts that we know are the things which transmit waves forward and draw a line straight through them in the direction of their motion. Tracing out light as rays allows you to do a lot of good analysis in terms of optics, refraction, reflection, diagrams, and all sorts of helpful tools for understanding what light does, why, and how. We'll start using ray diagrams in the next video when we look at the concept of reflection. Looking forward to that one. But for now, thanks for learning with me today.